Alright guys, in this video I'm going to graph a couple of quadratic trinomials. I'm given these two quadratic trinomials in standard form, the x squared, x, and then a constant. And what I'm going to do first is I'm going to rewrite them in perfect square form, and then I'm going to see what transformations that the function has undergone from the basic function of y equals x squared. And then I'm going to take a couple of points and see and actually transform them in that way. All right, so the first thing I'm going to do is I'm going to write my first function, x squared minus x plus 1, in the form of a perfect square. And so I'm going to complete the square. So my function is x squared minus x plus 1. And to complete the square, what I'm going to do is I'm going to write minus x, I'm going to put a parentheses here, and here plus 1. And what I'm going to do is I'm going to look at the coefficient that's on my x term. In this case, it's minus 1. I'm going to take half of that. Half of minus 1 is negative 1/2. Square it and add it on. Well, negative 1/2 squared is a quarter. And so I add on here plus 1/4. Because I'm adding on here a quarter, I have nothing out in front that this quarter is going to be multiplied by. And so I can simply subtract here 1/4. Here I now have inside the parentheses a perfect square trinomial, and that perfect square trinomial is x minus 1/2, all squared. I have here 1 minus a quarter, and so that gives me 3/4. And that's it. I'm now in perfect square form. And what this has allowed me to do is I can now see what transformations have taken place on this quadratic compared to the basic quadratic of y is equal to x squared. And so what has happened is that the function, I will write f of x equals x squared. It's my basic quadratic. Well, that function here the x has been replaced by x minus 1/2, and 3/4 has been added to the function also. What is the effect of this x minus 1/2? It is to translate the function to the right in the positive direction 1/2. That is the transformation that has taken place. And this 3/4 right here, that translates my function vertically upwards a distance of 3/4. All right, so what I'm going to do now is I want to consider some points that are on this function, and then I'm going to consider what transformations those points are going to undergo, or how those points are going to change. And so a couple of points that would be on the f of x equals x squared, I'll just take 3. Might be negative 2, 4. That is a point on f of x. I'll take 0, 0. And let's say 1, 1. Those 3 points are on my original function. Okay, so looking at my completed square form, this x minus 1/2, as I said, this translates it horizontally in the positive direction. In other words, all my x values that are on this function here are going to, because my new function is going to be translated to the right, all those x values are going to increase by 1/2, positive 1/2. And so, I'll just make a note here. This is the only effect on the x values. And so I can stop right there and I can say, all right, well, my x values then will increase by 1/2. It will increase by 1/2 on my new function. This minus 1/2 will have no effect on my y values. This is a translation only in the horizontal, and so it will only affect the x values. This 3/4 here is, as I said, is a translation upwards. It's a vertical translation up by 3/4. This will only affect my y values. How will it affect them? All my y values will increase by 3/4. So my y values, put parentheses around this, these will increase by 3/4. Okay. So what will be my u points then on my this function right here, on this function? Well, minus 2, 4, minus 2, I add on 1/2, that will give me negative 3 over 2. 4 increases by 3/4, that will give me 4 to the 3/4, or 19 over 4. And so, this point on my original function f of x equals x squared will be, if you like, it will be transformed to this point. Minus 3 over 2, 19 over 4. It'll be translated to the right and up. 0, 0. Well, I add 1/2. Well, 0 plus 1/2 is 1/2. And 3/4. Right there. I add 1/2 and I add 3/4. And here, 1, 1, I add 1/2. That will give me 3 over 2. And I add 3/4 to 1, and I will have 1 and 3/4. Or 7 over 4. And so these 3 points are now on my original function, are these 3 points on this function here, or this function here if you like. And so I'm just going to plot these 3 points. Minus 3 over 2, and draw a rough sketch. So minus 3 over 2, and this here is 4 3/4. So minus 3 over 2 is minus 1.5, which is right there. And 4 3/4 is approximately there, and so that will be that point roughly there. It's just a rough sketch. That point, here I have 1/2 3/4. Well, that there will be 1/2, and 3/4 is approximately there, so I will have a point about there. And then finally, this point will be 3 over 2, that's 1.5, so that is about there. And 7 over 4 is 1 3/4, so that is approximately there. And so that will be that point right there. And so I just chose those 3 points. You can choose 3 different points if you want, just so I can get an idea of my function. And my parabola is going to look like that. That is what it's going to look like. And so my original function, f of x equals x squared, the vertex is at the origin. It has been shifted to the right by 1/2 a unit, and it has been shifted upwards vertically 3/4 of a unit, and there it is right now. That is my function. That is the transformation that it has undertaken, and that allows me to graph then x squared minus x plus 1. This is this function right here. All right, I'm going to do one more. Keep my graph, I'm going to use it. I'm going to take this second function. I'm going to do the same thing. I'm going to get my f of x equals x squared. I'll write that again in a second. But my new function is minus 2x squared minus 12x minus 13. And again, what we're asked to do is to complete the square. All right. I'm going to start off by factoring out this negative 2 out of these first 2 terms. So that gives me negative 2 on x squared. Factor out a minus out of here, I'm left with a plus. Factor out a 2 out of 12, I'm left with 6x minus 13. All right, now I'm going to complete the square inside the parentheses. That is minus 2 on x squared plus 6x. We'll leave a space here to complete the square. And I have minus 13. The coefficient on my x term is 6. I take half of 6, that's 3. Square it and add it on. 3 squared is 9. And I add plus 9. I do have a number out in front here now that is other than 1. In this case, it's minus 2. And so the effect of adding this plus 9 is to, in fact, subtract 18 from the function overall, because this 9 is multiplied by this negative 2. That's negative 18. And so in order to make everything equal, I have to add 18. I have to add 18 to my function overall to balance it out. All right, if I've done everything correctly, will be a perfect square trinomial. So I have minus 2 times x squared plus 6x plus 9 is actually just x plus 3 squared. This is minus 13 plus 18, that is plus 5. And that's it. I've rewritten my function in the form of perfect square form. And this now again allows me to see what transformations this function has undergone as compared to the basic function of f of x equals x squared. If you like, if f of x is x squared, then this function here is minus 2 times f of x plus 3 plus 5. That's this function right here. All right, so some of the points that are on my original function, again, maybe I'll just choose, this time I will choose minus 1, 1, 0, 0, and 1, 1. Now let's just see in what way are these 3 points translated, moved around, transformed. All right, well, a couple of things have happened to my function. It has been translated to the left 3 units. That is because I replaced x with x plus 3. That is a translation in the negative direction 3 units, horizontally. It has this minus out in front. It has been multiplied by a negative 1, if you like. And so this minus is going to reflect it about the x-axis. So it's been reflected about the x-axis. This 2 is going to dilate it. It is going to be stretched horizontally. Sorry, pardon me, vertically. It's going to be stretched vertically by this 2. So it has been, so far, it has been translated to the left. It has been reflected about the x-axis, and it has been stretched vertically. It has also, this plus 5 means that it has been translated vertically upwards, 5 units. So essentially 4 things have happened. So what is the effect of that then? Well, the only effect on the x coordinates of my points, minus 1, 0, 1 here, is this plus 3. This translates it to the left 3 units. And so my x values will decrease by 3. And so my x values will go down by 3. All right. How about the y values? Well, the y values are actually, first off, multiplied by negative 2. All of my y values are multiplied by negative 2 because of the reflection about the x-axis and by this vertical stretching. So the first thing that's going to happen with my y values is they're going to be multiplied by negative 2. And then, because my graph has been vertically translated upwards 5 units, that is going to add 5 to all of my y values. So I'm going to also add 5 to all of my y values. All right, so what does that do? Well, my new function, or this function if you like, will have my x value here is minus 1. That will be multiplied, that will subtract 3. So minus 1 minus 3 will give me minus 4. The y value will be first multiplied by negative 2. 1 times negative 2 is negative 2. And then add 5. Negative 2 plus 5 is 3. Here, for this point, my x value is 0. I subtract 3, minus 3. My y value is also 0. 0 times negative 2 is 0, plus 5, and I have plus 5. And then finally this one, I have 1 minus 3, that's minus 2. And this 1 times negative 2. 1 times negative 2 is minus 2, plus 5 is 3. And so I have, these 3 points are the points that are on this function right here. Let me just plot them. Minus 4, 3. Minus 4, 3 will be approximately here. Minus 3, 5. That's minus 3. This is 5 right here. That's my new vertex. And this one is minus 2, 3. That's minus 2, 3, which is right here. And so with those 3 points, I can get an idea of what my parabola looks like. Comes up here, flattens out, comes back down through this point, keeps going. If I wanted, I could also find the x-intercepts by using the quadratic formula, perhaps, to solve my quadratic trinomial. That would give me 2 more points here. It would give me the x-intercepts, etc. But that's it. That's what we have completed the problem. We have taken our 2 quadratic trinomials. We have put them in completed square form. We have examined them to see what transformations they have undergone. And then we have applied those transformations to 3 points that would be on the original basic form of the function. In this case, that's f of x equals x squared. That gives us these 3 points. We plot those 3 points on our Cartesian coordinate plane, and that gives us an idea of what our new function looks like. All right, so that's how we do those kind of problems.